Have you ever wondered how heat transfers? It's a phenomenon that is all around us. Each day, from the moment we wake up to the time we go to sleep, we interact with heat transfer, often unbeknownst to us. The concept of heat transfer might remind you of your science classes in school. You might remember learning about conduction, convection, and radiation, the three different methods that explain how heat travel from one place to another. Perhaps you remember the hot stove and how the heat was conducted through the metal pan to the food you were cooking. But it's not just in the kitchen. Heat transfer happens everywhere. Consider the warmth of the sun on a bright summer day. That's radiation, heat transferring through empty space, or picture the air rising from a hot pavement. That's convection in action. Not to mention the warmth we feel when we put on a cozy sweater, that is transferred via conduction through direct contact. Isn't it remarkable how heat transfer influences our daily lives? It impacts everything from the food we eat, the clothes we wear, to the comfortable temperatures we enjoy indoors thanks to our heating and cooling systems. It's an integral part of our existence, and yet we often overlook its significance. So the next time you feel the warmth of the sun, cook a meal, or put on a warm jacket, remember, you're experiencing heat transfer. It's a fascinating topic that we encounter in our daily lives, often without realizing it. Let's delve into the first method, conduction. This intriguing process, which we encounter on a daily basis, involves the transfer of heat energy through direct contact between particles. Consider this simple yet illustrative example. If you've ever spent time in a kitchen preparing a comforting meal on a chilly winter's day, you've almost certainly come across this phenomenon. Imagine, for a moment, you're stirring a pot of homemade soup. The aromas wafting up from the bubbling broth are enticing, and you've placed a metal spoon in the pot to stir the ingredients together. Now, imagine reaching for that spoon. As soon as your skin makes contact with the spoon's handle, you instantly feel a surge of warmth. You've experienced conduction firsthand, a process so seamless that it often goes heat from the soup, travels up the length of the metal spoon, causing it to become noticeably warm to your touch. It almost seems as if the spoon is alive, radiating the heat it has absorbed from the broth. This is because the particles in the metal spoon are closely together, allowing for an impressively efficient and rapid transfer of heat energy. This everyday occurrence is a perfect demonstration of conduction. It's as if nature is providing a physics lesson right in our kitchens. Getting an understanding of these basic scientific principles can help us appreciate the world around us in a whole new light. Next on our list is convection. An intriguing phenomenon. It is a method of heat transfer that we often witness in day-to-day lives, though we may not always be aware of it. Convection predominantly occurs in fluids, a term which in the physical sciences encompasses both liquids and gases. Now, to understand convection, imagine a pot of water placed on a simmering stove. Picture the increasing heat from the stove gradually transferring into the pot. The water at the bottom of the pot, being closest to the source of heat, starts to warm up first. As it heats, it begins to expand and becomes less dense than the cooler water above. Consequently, the heated water rises, pushing the comparatively cooler water at the top downwards to replace it. This displacement sets off a fascinating dynamic in the pot. The previously warmer water, now at the top, starts to cool down, becoming denser, and it sinks back to the bottom of the pot, while the cooler water at the bottom gets heated and rises. This cyclical process of the warmer water rising and the cooler water sinking creates a sort of swirling or a circular motion in the pot. This very movement, this circulatory pattern driven by temperature variations, is what defines the essence of convection. It's an intriguing play of physics, manifesting subtly and continuously in our surroundings and contributing significantly to the transfer of heat in various mediums. This swirling movement is convection in action. Finally, we have radiation. This phenomenon in the realm of physics is an incredibly fascinating one, as it deals with the of heat energy through an intriguing method known as electromagnetic waves. Unlike conduction and convection, which are the other two modes of heat transfer, radiation doesn't rely on any direct physical contact between the source and the receiver of heat, nor does it necessitate a medium such as a gas, liquid, or solid to travel through. It is a free-ranging method that works even across the vast expanses of the universe. If we take a moment to think about it, the concept is genuinely remarkable. The fact that heat can be transferred through nothingness, through the void of space, is something that defies everyday experiences and expectations. It is a testament to the strange and wonderful laws that govern the universe in which we live. A prime example of radiation, one that vividly illustrates this concept, is the sunlight reaching the Earth. The sun, a raging inferno of fusion, is located an astounding 93 million miles away from us. Despite this enormous distance, the sun's heat energy manages to travel all that way and reach us here on Earth. This is only made possible thanks to the incredible process of radiation. Without it, our planet would be a dark, cold place, devoid of the warmth and light that are so crucial to life. Even though the sun is millions of miles away, its heat energy can still reach us thanks to radiation. Now, to summarize, conduction requires direct contact between particles and is common in solids. This vital process is seen prominently in solid substances due to the close proximity of their particles. Conduction enables heat to transfer from areas of high temperature to those of lower temperature. On the other hand, convection involves the movement of heated particles within fluids. It's a primary heat transfer method in liquids and gases, where warmer particles rise and cooler ones sink. Lastly, radiation is the transfer of heat through electromagnetic waves, requiring no medium or contact. It is the only way heat can transfer in the vacuum of space. Each of these methods plays a crucial role in how heat moves and spreads, shaping our world in ways both big and small. This phenomenon, often unnoticed, is constantly playing out around us, impacting the most mundane to the most profound aspects of our lives. Whether it's the intense warmth of a summer day or the comforting heat from a cup of hot tea, these processes are tirelessly at work, subtly shaping our experiences. These processes, so commonplace, often go underappreciated and unnoticed. So when you next enjoy a warm beverage or bask in the sun's radiant heat, remember the incredible science of heat transfer that's making it all possible.